Ionic bonds tend to form under two certain criteria. And the first is ionic bonds tend to form between metals and nonmetals. So if you have two elements and one's a metal and one's a nonmetal, an ionic bond is likely to form. Now the second criteria is that ionic bonds tend to form between elements with a large difference in electronegativity. So the larger the difference in electronegativity, the better the chance ionic bonds are going to form. And so if elements meet both of these criteria, there's a very good chance they're very likely to form ionic bonds. Now, keep in mind that elements with the highest electronegativity values are in the upper right-hand corner of the periodic table of elements, while those with the lowest are near the lower left-hand corner. So you have elements with low electronegativity down here, and elements with high electronegativity up here. And so just by knowing those two facts right there, if you see an element on the periodic table, if you just imagine this board as the periodic table, and it's about right here, you just know by where it's geographically situated on the board that there's a really good chance that it has a high electronegativity because it's near the top right-hand corner of the periodic table. Now, I have some pairs of elements here, and I want to examine these elements to see if they meet this criteria and determine whether or not they are likely to form ionic bonds. So first we have nitrogen and oxygen. Now, nitrogen is a nonmetal, and then oxygen is obviously a nonmetal. So they are not likely to form ionic bonds because there is not between a metal and a nonmetal. We have two nonmetals here. Then we have potassium and fluorine, and potassium is an alkali metal, and fluorine is a nonmetal. So we've met the first criteria. We have reaction here between a metal and a nonmetal. So we're doing good so far. And then there's a high electronegativity difference here, and it's actually 3.2, which is pretty high. So they're likely to form ionic bonds, specifically potassium chloride. Now here we have barium and sulfur, and barium is a metal, and then sulfur is a nonmetal. So here we have a metal, a nonmetal. We're doing good so far, so they're likely to form ionic bonds, specifically barium sulfide. And then in addition to that, their electronegativity difference is moderately large at about 1.6. Now finally, we have cesium and tin. And cesium is an alkali metal, and then I'm sure you can guess that tin is a metal. So here we have two metals interacting with each other, so it's not between a metal and a nonmetal. So these cesium and tin is not likely to form ionic bonds. So notice here the main factor here was that we had two nonmetals and two metals here. But when we have a metal and a nonmetal, they're likely to form ionic bonds, and especially if they have a high electronegativity difference. So hopefully through this short session, you have a better understanding of ionic bonds.